All right, that should do it. Mm, Just testing 1, 2, testing 1, 2. Just testing 1, 2, testing 1, 2. All right, let's see. Everything seems to be working. To mute this, go here. Hello and welcome to a live rehearsal of Mr. Hal, Computer Mentor. Today we'll be working through a computer exercise. It's going to be pretty simple. Since I don't have a learner right here now to mentor, I'm going to be working with a AI chatbot based on ChatGPT that I whipped up. And yeah, it should be fun. So to start off, I'm going to be going over the background of this project we're working on. So we're going to be implementing a encryption algorithm, one of the strongest encryption algorithms available. It's called a one-time pad, and even though it's one of the strongest encryption algorithms available, there are a lot of downsides. For instance, the key length has to be equal to the message length or else it won't work properly. It'll be breakable. So we're going to be implementing that. It's going to be fun. Here, let me introduce, drum roll please, AI chatbot named LearnerBot. You ready? We're live. See if this works. I've given it kind of this attitude, this personality or pseudo personality. So I'll let it know that we're going to be implementing a one-time pad encryption and decryption algorithm. Now, the first thing to determine is what programming language we're going to use. So I'll ask LearnerBot what it wants to do. However, one thing I've learned about this is it always picks Python. So I'll ask it to select between two randomly, either Python or let's say C#. Pick one at random, please. And we'll see if it picks Python like it usually does. All right, we're going with Python. Excellent. So I think I've got Visual Studio Code set up for everything. I'm going to need to initialize a new repository for that. So let me close this workspace I've got and do a new project. I guess I have to go into the command line. Let's see, terminal. Yeah, terminal, maybe? No. All right, here we go. Python. We have a new folder. Let's see if we can just open that. Good. And we're going to build a new Python called, what shall we call it? OTPad Pi, I guess. Crud. Give me a moment. I'm a little bit new to Visual Studio Code, so I guess what I need to do is save it as OTPad Pi. Got that. Next up, given a one-time pad, you need both a key and a plain text. And that's for encryption. You need a key and a plain text, and if you're decrypting you'll need a key and a ciphertext. We can represent those as strings at first, so we'll have to convert them to numerics at some point, possibly in an array or a loop. Let me see what what LearnerBot has to say. Excellent. Python it is. Now, we need to store a key and a plain text for encryption. How does that sound? I think it's strings. How does that sound to you? Sounds good. So, our plain text, and I'm not going to do exactly what it's saying. Our plain text, I like to keep it simple. So I'll just say hi. That's our secret message that we're going to encrypt. Now our key has to be the same length as the message or it won't be secure. It could also be longer than the message, but we'll have our secret key be SK for secret key. So we've got a key and a plain text. Now, we're going to have to convert the first letter of the key to encrypt the first letter of the plain text, and we're going to have to convert those into numbers. I don't believe Python can just do the mathematical operation on the strings that we need it to do. So, here we go. I do not recall. So, sounds good. Learn about saying strings, classic choice, simple, clean, and no risk of me accidentally turning it into a list of integers and breaking everything, probably. So we'll need a plain text message and a key, right? Like this. That's the vibe, or am I already off the rails? Sounds good. Now, what's the Pythonic way to convert a character in a string to a numeric integer? Because we need numbers. Encryption algorithms work on numbers. They're mathematical algorithms. It's probably something like 2 ASCII or something. Oh, it's ORed. Good, good. So we need to go through each character of the plain text and each character of the key, converting them into numerics, integers, numbers. Okay, so how do we do that? I am really rusty. I haven't used Python in a while. I believe it's going to be 4. And I think it's something like or index in range. And we'll go with the length of the plain text. I think we could do this. Len. Maybe it's better, be more Pythonic, to say len plain text. Now, we need to be sure that's not going to be off by 1. What have I got wrong? Colon, of course. Good. And now there may be a better way to do this. I wonder if Python can do a for each. No, it doesn't know that. Like I said, I'm really rusty, but this is going to be fun. Okay. Yeah, let's keep it simple and just use a for loop. So this is going to make index start at the first number, the first index of the plain text, 0, and then move on to the next until it reaches the end, hopefully. If it's not off by 1, we'll see. So we're going to get the first plain text value equals plain text index. So that should get us the value. And I put a semicolon out of habit. And key character equals key index. Now, normally when you're doing this, you'd want to check the ranges so you don't go out of bounds. But here I'm just quick and dirty. It's not going to be ASCII, so it may not be ASCII. It's probably going to be Unicode or something. So the integer of that is going to be ORed of the plain text character, and the key integer is going to be the ORed of the key character. So far, so good. Now, the important thing about the one-time pad is how it encrypts. It uses something called XOR or exclusive OR. It's easiest to see in binary. Let me see if I can come up with a good demo for that. So let's say you have, it's operating on, it's an encryption algorithm. So it's mathematics. So it uses numbers instead of natively understanding things like words and characters like we do. We're going to encrypt the number, I don't know, 7. This is just an example to explain how the XOR, exclusive OR, works for those of you who are interested. Let's say the key value is, I don't know, 3. And so the first step is to convert those into binary numbers. 7 in binary is 0, 1, 1, 1, I believe. 1, 2, 4, yep, 4, 5, 6, 7. 3 in binary is 0, 0, 1, 1. So we've got two binary values. And the encrypted version is going to be called the ciphertext. So the way XOR works is you go through each individual binary digit. And if they're different, you put a 1. And if they're the same, you put a 0. Since 0 and 0 are the same, we're going to add a 0 here. 1 and 0 are different, you put a 1. 0, 0. Because 1 and 1 are the same in both digits. Do, do, do. So this is just an example of how XOR works. Now the numbers for these plain text and key characters are going to be a lot larger. Even if it's an ASCII, I think they're going to be at least 33 in decimal. So that's just so you know. I chose a simple example for this. All right, here we go. In most languages, to do the XOR, what you want to do is ciphertext integer equals plain text integer with this hat key integer. There we go. And that should encrypt one of our characters. Now, we're going to output this, I believe, into an array or a list. I'm not sure what Python uses for those. I'm pretty sure that's the way no, we can use a string. Of course. So we're going to have an empty string here. And then we're going to add, if it's ORed, to convert the character to an integer, what would it be to convert an integer to a character? Let's see. I betcha it's something like cur. Yeah. Equals ciphertext integer. And then we add that on. Let's say, oh, it doesn't know this? Yeah. Ciphertext integer ciphertext. Give me a sec. I may have made a typo somewhere. Then our ciphertext equals, we need to concatenate cat, and concatenating strings in Python is not something I remember. Maybe it's plus. We're going from index 0, the left side, to the right side. So character plus ciphertext. Let's see if anybody's in chat with questions, comments. Give me a sec. No questions, no comments. That's fine. Moving on. This is just a rehearsal, so let's go. Got that. Now, this loop, if I haven't made a terrible mistake, should give us 2 characters of ciphertext. Now, another thing to keep in mind is that these characters may not be printable They may not be, there may be some strange Unicode emoticons or in a different language or something. But we'll test it out and see. Let me put a breakpoint. Let me just print cipher text here. Ah, I see what I did wrong. Ciphertext. And break here and see if our debugger's up and running. We're going to debugger Python, see if that works. Yes, we stopped here. We've got our cipher text, which only includes the quote character. Now that's interesting. That doesn't seem right. The integer is 34. Index is 1. The key integer is 75 for a capital K. Plain text character is lowercase I, which is 105. I'm just sort of trying to figure out if this makes sense, and I don't think it does. Yeah, it's getting quotes for all of our characters. That's not what we want. Let me ask LearnBot. Boom, instant numbers. That's the move. Or did I reinvent fire with more bugs? Now that seems to work. Remind me of how to concatenate. Fancy word for put together, mash together strings in Python, please. And LearnBot is going to reply. Maybe I should just read the docs. It's saying plus operator. That's what we used. That's what I used, but it doesn't seem to work. Does CHR convert integers to characters? If so, what character set? Or perhaps a better word here would be encoding. 65, capital A uses Unicode, good. Oh yeah, CHR is like ORD, but in reverse. It converts an integer into a character, and it uses Unicode, so we're not stuck in old school ASCII land. It means we can do fancy stuff like emoticons. Did I flex too hard, or was that actually useful? Useful. Still got a bug. So this is what this is part of the concept of this program. I'm going to run into bugs, troubleshoot them live on air in real time, and walk everyone through the process of finding and fixing bugs in actual realistic programming projects. So here we go. This is not what happened. Nope, that's not it. So LearnBot thinks I'm accidentally mixing up my data types, adding a string to a numeric. And that's not what I did, I think. I'm going to double check that. LearnBot has a lot of good advice. So let me look at ciphertext. Okay, ciphertext is nothing, even though the character is a double quote, and the integer is 34. Do I have a terminal? Yeah, it's in use. How do I make a new one? Let's just bring up this. Python 3. We want CHR 65. Should be a capital A. Ciphertext. Oh no, how about 34? Ah, that's going to be a reserved, a double quote. That makes sense. Now, could it be? No. Why is cipher? Ah, it's scope. Found it. Maybe? No. Ciphertext is empty. Is it? Could it be immutable strings? Ah, it's a typo. Haha. Ciphertext. Got it. Silly me. Anyway, we're going to halt this or save. Then halt that. Then re-execute and see if we get anything better. I'm looking for two characters under our ciphertext, and we got two characters, I believe, a double quote and hexadecimal 1B. Now this makes sense. Because it's Unicode, we're not necessarily going to get a printable or even a valid character here, but the algorithm should have no problem encrypting and decrypting using these invalid characters. I'm going to push this up to a repo so anybody who wants can follow along if they so choose. And initial commit. This is a local repo. Give me a moment, please. What I want to do is commit it up to GitHub in one step, but I may have made a mistake and not be able to do that right away. Oh well. Commit. It's not a great message, but it'll do for now. Publish. Ah, Breck, give me a moment. Tables shifting. All right. Public repository. We are publishing. It is online. Excellent. So we've got a ciphertext. Now, one thing that's important is to double check our work. To do that, we're going to need each integer of the ciphertext. And this is just, well, let me see. Can I just execute some arbitrary Python here? We do not have, oh, debug console, heck yeah. Ciphertext is accessible. Word ciphertext. First character, 34. So we're going to do a binary calculation of the first character on the ciphertext encrypted by the first character of the key. And you might wonder why I would do this. The reason is going slow like this really helps you understand what's going on in the computer. It'll help you debug later, really understanding all of the steps, and it'll help you understand the algorithm, how the numbers are being used, and the operations. Let me quickly check to see if everything is looking good here. Yep. I'm gonna adjust camera a little bit. I need to go. Give me a sec. OBS. Yeah, it's a little bit better, more centered. Bring it in. Yep. Fine. Anyway, messing around. Gonna go back to code. Plain text is 72. The key is the next thing I need. Word key. And we're just going to check the first character of each of these. And of course, we could do the XOR by hand, but I don't feel like it. So, I wonder. I don't recall how to specify in Python the output base, but maybe there's a bin of the plaintext 72. Yes. So converting between bases is not something I need to practice right now, so I'm just letting Python do it for me. I always like to try and figure out, like, what do I need practice with and what can I let the computer do for me? So we got the ciphertext. We need the key, which is 83. Here's the binary. And so the ciphertext of the first character of our encrypted message should be saying 34 is the answer we should get. And the binary we get here is, since these are the same, we get a 0, 0, 0, 1, 1, 0, 1, 1. Then we convert it back to decimal. I wonder if we can just say 0b like that. Yeah, 27. Is that? That seems like a mistake. I think I did the wrong thing here. Hold on. No, this may be fine. Then find the character of 27. Excellent, excellent. Now, here's something a little bit confusing. Why did it give us the second character instead of the first one? And I think it may be because I put them together in the wrong order here. If I hadn't gone through the steps one by one, step by step, I wouldn't have caught that. So it's good that I did. What I'm saying here is add our new ciphertext character at the beginning. It should be at the end. Sorry about that. Here we go. Add it at the end here. Then execute again. And I think we just want to continue and run. See what we get. Yeah. Hexadecimal 1B and a double quote. That's our ciphertext. Now we're going to attempt to decrypt it. Let's see how LearnerBot is doing. Problem solved. All good now. What was the bug? Ah, one bug was a simple typo, but it's fixed now. Would you like to start? This is the mentoring part. Would you like to start on implementing the decryption algorithm? I can type. Algorithm. Algorithm is just a series of steps used to complete a task. It's sort of an abstract idea. It's not a specific, well, it can be very specific, but it's not any particular implemented program. So um, give me a couple of lines to start with. And another good thing about this is LearnerBot may use a different strategy than I did. But still, regardless of what strategy you use, if you use the same algorithm, you should get the same result. That's a very important thing to understand in computer science. Ah, ha. So, LearnBot says, ooh, decryption? Now we're talking spy movie levels of cool. Not exactly. All right, let's say we're dealing with a basic shift cipher like Caesar cipher. We'll probably start by taking an encrypted message and shifting the characters back, yeah? That a good start, or I'm about to get nice try rookie from you? Nah, we're doing a one-time pad. I think I got the. Oh, okay. Silly me. Um, Encryption and decryption in a one-time pad is the same operation. It's XOR. However, I'm going to have LearnerBot implement its own decryption, which it'll implement differently, but it'll be the exact same operation as my encryption, because the same operation does both encryption and decryption in a one-time pad. It's both use XOR. Now you do the decryption. Give me a couple lines of Python for that, please. Here we go. Let's see what it got. It may do something very much quicker than I did. Ooh, one-time pad. Now we're in serious encryption territory. Respect. All right, decryption for one-time pad is basically just reversing the encryption, right? we take the ciphertext and we XOR it with the same key. So yeah, he's building a function for us. That's good. So it takes the ciphertext and it takes the key and it starts plain text. Okay, that looks good. Better, even cleaner than what I was doing. So we're going to define decrypt, given a ciphertext and a key. Now, we may have trouble because these are already used, but I think it's going to be all right. Python needs colons everywhere. Plain text equals bladum. That's how you pronounce that, bladum. All right. Are we about to get schooled on cryptography? Nope. So far. What would you do next? Is he going to use a loop? Or, yeah, a different loop. Okay, this is better than what I did. I hadn't thought to use zip here. Like I said, I'm not familiar with Python and its loops. All right, let's get this cipher cracked. So choosing XOR for encryption, we just XOR each character of the ciphertext with a corresponding character in the key. Something like, that should do the trick unless I reinvented a new kind of encryption accidentally. What do you think? Okay, I think that looks good. I'm not terribly familiar with zip, but this looks like it'll work. So we're converting the character, yep, XOR with the key into numbers, then we're converting it back to a character and adding it. Yeah, that looks good. I am not being too methodical in checking the work of this guy. You should always make sure you know what your AIs are doing. But in this case, this looks good to me. Now, this is going to be plain text equals plain text plus. That's fine. Yeah, CHR, ord. And here it doesn't matter the order, but I'll do this. Ord K. And got it. All we have to do is return that, and we should be fine. Looks great. Next up is to return the result, right? Yep, easy peasy. Oh yeah, I can't forget to actually return the result. Kind of important. Boom, decryption complete. That should work unless I overlooked something obvious. Be honest, I'm going to get a rookie mistake from you. No, no, all good. I think. Won't know until I test it out. Let's go. Return plain text. Then we need to call our function written by LearnerBot. So I'm going to say decrypted equals decrypt. We're going to decrypt the cipher text with our key. And then we're going to print out decrypted. Decrypted. Now hopefully if we run this, it'll first print out the gibberish encrypted text. And that'll print out something that should match our plain text high. We'll see if it does. Execute. And continue off of that. Oh, did something go wrong? Hold on. Am I looking at the wrong thing? Everything looks fine here. Like we hit a breakpoint. Good. And we got one character of the decryption. Just I. Now it may be that when we outputted with the ciphertext here did something strange to our terminal, like deleting a character, or maybe it's a special Unicode character. So I'm going to comment out this for now. And we're going to execute this once more. Run. Yes, excellent. So there, we got our plain text back after we decrypted it using this function. Now, if you'll notice, what I wrote and what LearnerBot wrote are very different in their implementation, but they do the exact same thing. Like, for instance, if I were to say, instead of all this, I'm going to first run the decryption algorithm and then run my encryption algorithm. Do, do, do. Or it's actually an implementation, but you get the idea. So we're going to say cipher text equals decrypt. In this case, it's actually going to encrypt, but it's the same algorithm in a different form. We're going to decrypt the plain text with the key. That'll give us our ciphertext. And then we're going to go through that plain text and encrypt it using my algorithm. But we should get the plain text back, but it'll be called ciphertext. Let's see if that works. No, something went wrong. Let's see what could have gone wrong. I think it was just a simple mistake somewhere. I'm going to check on the stream right quick. Wrong thingy. Do, do, do. Wrong. I'm fumbling around. Give me a sec. I'm just looking for chat. Chat looks okay. Going back to our program. So, ciphertext is empty initially. Our ciphertext is give it the plain text and the key. We got the ciphertext. We go through the plain text one by one, which is here. So the problem we're seeing is ciphertext is empty. Let's use a breakpoint here and see what we find out. And we're going to continue off of this one. See if we can, yep, see what decrypted looks like. We've got our ciphertext. That looks right. Yeah. And then we're going to step through this. Plain text character H, key character H. Now, S. Looks right. It's because it's hard coded here. My mistake. We want to halt this. And instead of looping through the plain text, we're going to loop through the ciphertext. So we've got this, yeah. Grab the ciphertext character here. All this looks fine, I think. And we'll see if it works. Execute. And we've seen this before. It's because it's outputting our encrypted message, it looks like, at some point. Where are we doing that? I don't see that being done anywhere. Or it could have been because it's not going through the entire string. It's going for index and range of the length of plain text, which is high. So length should be 2. Plain text character, ciphertext.index should be 0. Key character. That looks right. Plain text integers. Ordinal plain text. Okay, let's step through this again and see if we can figure out what went wrong. So we're doing an iterative strategy where we basically step through one at a time, fixing bugs one at a time as we encounter them. The plain text, okay, that makes sense. The key character is S. The plain text integer is 27. That makes sense. The key integer is 83. Now let's see if it properly, okay, ciphertext character. Hmm. H. All right, that looks right. Ciphertext. Already has stuff in it. That's what's going wrong. Yeah. So we need to halt this. Plain text. Perhaps. Hold on. I'm confusing myself because I'm rushing, and you've got to be methodical when you're doing programming. So the problem is ciphertext isn't cleared, but I don't believe it can be cleared here. We're using it. Now, how about plain text? Are we using that? Yes. Let's just grab a new variable here. We'll call it decrypted. If we don't already have one, and we don't. Decrypted. And we're going to print out decrypted. And one of the things about computer science is with practice, you'll learn to avoid all of these issues. You learn to avoid issues one at a time as you run into them. And I've run into another issue. Decrypted equals decrypted plus. It's really fascinating how you build up a little at a time, getting better and better with practice. It's definitely a practice. It's not something you can learn all at once in a class or anything. It's something you have to learn and relearn if you take a break or if you pick up something new. It's not always applicable, everything in one domain to another domain. You can't take everything you learn in C# or algorithms or data structures and apply it to databases or encryption algorithms or anything like that. Each domain has its own sort of nuance, stuff you can learn. Anyway, we've got this project pretty well in hand, I think. Looks pretty good. I'm going to push this. Encryption and decryption. We're going to commit that. Sync the changes up to GitHub. And we're pretty much done at this point. Let's see. It's only 150 local approximately. Right. Ran into a couple bugs while testing out a demonstration that the encryption and decryption are symmetric in a one-time pad, but we worked through them. Ah, citrusy is here. Let's see. Hello. I really need to fine tune how this is looking. do. Ah, neat. The chat up there on the top right is working. Excellent. Ah, give me. I'm going to be going to bots and see. Hey, we debugged it. That's what I'm talking about. What were the bugs? Let me guess. I forgot to check if the key and ciphertext were the same length, or maybe I accidentally summoned an ancient encryption demon. Lay it on me, Hal. What went wrong? It was all me. I was just a little sloppy with my variables. At any rate, what should we do next? Let's see what LearnAbot has to say. Probably something way too ambitious. Oh snap, Hal, only up to a mistake. Mark this day on the calendar. All right, next up, we should probably write some tests. That's an excellent idea. Maybe throw in some asserts, or do we want to get fancy with automated unit tests? I think unit tests would be a great idea. However, I am completely unfamiliar with unit tests in Python, but this is a great day to learn. Let's do some automated unit tests. What's a good test suite for Python and VS Code? Let's see what chat's up to. Looks good so far. Excellent. Thanks, Citrusy. I really want to do like text to speech, but I haven't quite got that working yet. Ooh, getting serious with testing. I like it. For Python, PyTest is the GOAT for unit testing. Super simple. No need for boilerplate test classes. Just write functions, add assert, and boom, done. I like it. VS Code plays nice with it too. Just install PyTest, and VS Code can auto-detect tests. Want to start with a basic test and see it in action? Heck yeah. Please hold for my next prompt as I install PyTest. All right, I'm going to see. Now, there's a thing with pip on Ubuntu by default. It won't install, if I'm not mistaken, this package because of something about the environment being managed. So what I want to do is use what's called a VN for virtual environment for Python. We're getting pretty fancy here. I'm going to install Python global can cause packages. Ooh, it looks like VS Code has got my back. Let's just click this button instead of trying to remember the command line. That sounds good. Go for it. Python interpreter. Let's use 3.12.3, Python 3. Let's go ahead and use the one in bin. Creating environment. Upgrading pip. Pip is a Python package manager. Now it's installing packages for PyTest into our virtual environment. With virtual environments, you have to activate them. And the way you do that is, let's see what it named it. .venv bin activate will activate our virtual environment. I thought. Let's see. Well, that's surprising. Normally, you have to activate them like that. But I think, what's it? VS Code has done something a little bit different here. Oh well, we'll see. Now, need to figure out, let me try to figure it out for myself. Python 3. And we're going to import PyTest. It's not picking it up from our virtual environment. That's a problem. Now, how do we activate our virtual environment? Find here, name, activate, type file, and what else we need? Anything? Aha, that's what I thought. Vem, then activate. Permission denied. So whose is it? L, Venv, bin, activate. So we're troubleshooting live on air to give people a sort of an idea of how programming works in real time in the real world. Because it's not going to work the first time, almost ever. So I think what I need to do is I need to source it into the local environment, the Linux thing, and activate. We'll try that. Excellent. And you see that .vm at the beginning of my prompt? That means I'm in the virtual environment with all the packages I need. So here goes. Should be able to pick up PyTest. Import PyTest. Help PyTest. See if that works. Yes. Unit testing. See, I go to local docs. People these days will go to an AI or Google, but I like going to the local docs. It's old school, kicking it old school. So, scanning through here for anything I can use. We've got reports. We've got a mix-in. Exception. Neat. Lookup error. User warning. So this is just a list of everything it can do. Here's a class cache. We probably don't need that. What else we got? Call info. Are there any examples here? Maybe we ought to go to something a little bit faster. Let's ask, okay, LearnerBot's all alike. My guy's on it. While you're installing, quick question. Do you want to test the encryption function first, or should you go straight on for full encryption, decryption, cycle tests? I'm thinking we throw in a couple of edge cases too. Empty string, super long key, maybe a key that's shorter than the message itself to see if it explodes. Oh, it will definitely explode. Let's do simple tests of the function first. I tried documentation, but it is very dense. So, could you school me on PyTest right quick? Here goes. See if it's probably going to give me a little snark. Since I'm supposed to be the mentor in this case, and this is supposed to be the learner, but at any rate, yeah, snark. All right, PyTest 101. Right, test function, test crypto pi. Each test function is with test underscore use assert. Assert encrypt. Yep. PyTest in the terminal. You want to write the first test together? Sure thing. Sounds fun. So I'll make a new, I'm going to call it test underscore otpad pi. Otpad pi. Hit a test, and we'll call it test, I don't know. I guess encrypt is good. Encrypt function. Give me a moment while I do that and hold for my next prompt. See, LearnerBot is really eager, chomping at the bit to write this whole thing for me, and I don't want it to. So I'm always telling it to hold for my next prompt. All right, let's go back to VS Code and give it a new file here. And call it test, I believe, otpad pi. And define, was it test encrypt and assert. Now, we want to do a very simple test first. So we're going to run remember, decryption and encryption are the same in this algorithm, so we can use our decrypt to do encryption. Crypt. Now it's not finding decrypt, so I wonder if I can just import. I'm not sure this will work at all. Otpad. Ooh, nice. Does that do it? All right. Now, if you recall, with the one-time pad, it uses a exclusive OR operator, which means if there when there are differences in the binary, it'll. I was about to ask if you knew about VM. The master can always learn from the student as well, at least from my experience. Just don't happen as often. Thanks, Citrusy. Anyway, I was thinking we'd do something simpler than the example it gives us. Given a one-time pad, if you give it the same value for the key as you do the message, they're identical, so the result should be 0 or null. Assert this A equals CHR 0. Now, I'm not 100% sure this will work, but we'll give it a shot. What is it complaining about here? Can't find it? Decrypt is not define a pilot. Okay. Oh, yeah. Hold on, maybe. Yeah, got it. I need to tell it, decrypt is an OT pad, and I have one too many close parentheses, looks like. So this is looking good so far. Now I need to execute it. It said PyTest. Ooh, neat. Collected one item, one passed. Excellent. So our first test passed. Key equal plain text. Yep. So let's try another. We're going to do a little test-driven development now. With a, let's see, a null key. So if we don't give it a key, I expect it to fail. We're going to assert OTPad. Now, it really should give us some sort of reasonable error message in this case. I'm going to give it the ciphertext A and the key empty string. We should assert that this will give us an error message. It's not going to because it's not designed to yet. What error should this give us? We're going to encrypt or decrypt a plaintext A with a null string. All right. Wrote my first PyTest, and it worked like a charm. First time. Now, how do I assert an error will be raised given an empty key in PyTest? Let's see what LearnerBot has to say about this. LearnerBot sort of has all the knowledge of mankind, but doesn't have a lot of confidence. Oh, you get you, Mr. Works first try. Don't get used to that. Bugs are lurking, waiting for their moment. All right, to assert an error in PyTest, use PyTest raises. All right. I'm going to try throwing some really cursed inputs at it. Not yet. Errors or exceptions are available. Is value. Hello. It's all right. Is value error the correct one to raise? Or is there a null or empty parameter error we could use? So I have Program Learner about to try to make some mistakes, just sort of reasonable ones, realistic ones, and we'll see if it does. The moderator API jumped in and decided to censor us, but I think we can get around that. Arg, accursed moderator. And I have no idea why it chose to jump in here. Still working on the kinks with the blasted learner bot. All right, let's try giving it a different reply. What exceptions? What errors are exceptions? Raised in Python. There's an empty string error or um, required value empty or not supplied. See what LearnBot has to say about this. And hopefully it won't be rejected by the moderation API for no reason I can tell. And it was. Well, let's just dive in and see what we can do. Assert PyTest. We're going to need to import PyTest, I assume. Import PyTest. Assert PyTest.raises. Expected exception. Okay, what exceptions can we use? Well, value error is apparently 1. And here's the func. Now it's looking for a lambda expression, so I think I do that. Or maybe that. Yeah, that looks good. And it needs another close parenthesis, I think. It's complaining about something. Oh, it uses a space? No, it says not closed. We open, 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 close, open, close, close, close. Looks closed to me. So I'm thinking there was something wrong with my lambda expression here. Let me see. LearnerBot. Communications test. See if it gets censored by the moderation API for whatever reason it's not working. LearnerBot may be down for the count at this point. We'll see. I can try restarting it. Yeah, I think it's dead. So we're gonna have to go without. Here we go. Python lambdas. A lambda is like a snippet of code you can activate like a mini function without even giving it a name. None of these are looking like the lambda I'm trying to use. It's using lambda. Maybe I need arrow function. Arrow function. It's a function annotation. All right, so it's not a lambda. I thought it was a lambda, but I made a mistake. And as I always say, if you're not making mistakes, you're not learning. All right, here we go. I don't believe we need this arrow function. Can we do this? I wonder. We'll give it a shot. And execute our new test. And excellent, excellent. It says it has to be callable. So it needs something callable like a function. Can we just say, given this is Python, maybe we can say lambda colon? Ooh, neat. That's pretty sweet. Let's see if it works. Yes, yes. Did not raise value error. Failed. Now, I am wondering, can we go in here, put a breakpoint in, and see what's actually going on in there? We would want to debug our test. Is there an option to debug tests here? Yes. Attempting to debug our test. Nothing seems to be happening yet. No test found in selected file or folder. Well, that's clearly false. Moving on. 209 local. We're gonna probably end up around 3 p.m. ish, 3:30. That's US Eastern time. Now, why did it say no tests found, I wonder? Let's see if we can just use this to debug Python here. Yes, yes, it's working. And then we're going to continue here. Okay. Interesting. So it's running this because it imported it. I see. So this is just from the import, encryption and decryption. And it did not execute the test as it should. Let's see if we can testing, configure, PyTest. I believe root directory. No results yet. Ah, test results. Here are our tests. Excellent. I'm liking Visual Studio Code so far. As I said, I've never used it before, so it's really exciting getting to test it out live and see how it works. What have we got? Do, do, do. Ah, I think I did the wrong thing. Here we go. So it's just running this, going through this loop, and here with a null key. And we're going to step through this slowly and carefully. Does this raise an error given a null key? It does not, it just skips it. So it's going to just return an empty string, which is not the right thing for it to do. Excellent. It didn't do anything to crash or burn as I expected. So what we're going to say is if the length of the key does not equal the length of the ciphertext. I need a colon. We're going to raise a value error. See if that should fix our test. Let me look at our test. Yeah, it's saying this test failed with a null key. Now we're going to run it again, and it passes. Excellent. Let's commit our changes. Implemented a couple unit tests here. Commit that. Look into Discord. Nothing new. Yeah, I think I'm going to have to do something about LearnerBot. Let me see if I can get into the shell of that. I now nobody hack me, please. SSH LearnerBot key just how at learnerbot.u dot west us2 dot azure dot no. I'm just hoping I can remember this. Okay, is that right? That is not right. It's either US West or West US2. All right. LearnerBot. We are online, I believe. Yeah, everything looks good. Uh-huh. I just got the domain name wrong. Not that either. Wrong, yes, West. Azure com. Yeah, this will be fun and educational. Try and troubleshoot my bot live on stream. Is this the one? That seems risky. Here we go. LearnerBot VM, virtual machine. Go away. Ubuntu, there's our IP. And we're going to minimize this. See if we can get to that. Yeah, I'm using authentication mode, so it should be pretty safe. See if this works. Maybe it's down. The virtual machine. VM activity log, maybe. I don't know. No events. Overview. Running. that, user, that. Perhaps it's doing an update or something. I'm going to ping it with one ping only. And no response. How strange. So we're online. Let's go ahead and try restarting. I wonder if maybe I have a hypothesis. What if our logs were too much for the server we have? That would be kind of funny. But this seems dead. Perhaps I should try a different network connection, but I don't have one right now. At any rate, let's get out of this rabbit hole and close that. So yeah, I think this project is pretty much done. We've got a unit test, we've got GitHub, we've got debugging. We've demonstrated that the encryption algorithm for the one-time pad is identical to the decryption algorithm. I think we're gonna wrap it up. Is there any questions from anybody? Any questions, comments, ideas? Let's see. OBS. That. Everything looks good here. Perhaps we should start on another project, but do we have time? We might have time. Or we could do some more equipment tests and checks. Just sort of thinking out loud. No, I think we ought to wrap it up here. Thanks, everybody. Thanks for watching and tuning in. And look forward to the next episode. It's going to be on next week on the 22nd at 1 p.m. Eastern. All right. And it will be better than this one. This is just a rehearsal, getting my getting everything done and prepared. Oh, shit. All right. And I'm going to, I think that's, oh yeah, I've got that.